I would like to share some recollections from back when Kotlin started. And I welcome your questions at any point in the talk. I will make some pauses and ask for questions actively, but you shouldn't hesitate to just put up your hand and ask right away. Yeah, if you want to contact me at any point, I'm a Breslov everywhere. So Twitter, LinkedIn, anywhere you like, you can find me. Okay, this disclaimer I've already given you. So the story begins back in the year 2010, when the word Kotlin was not in any way associated with this project, and the project was not even started properly. So I'll give you just a little bit of my personal context, the context of the company, and a little bit more context that's relevant. So back in 2010, I was 26. I was teaching programming, algorithms, software design, nothing related to compilers at all. At the university, at high school, I was doing a part-time PhD without a proper advisor. Like, my advisor was a very good mathematician who had no idea about programming, computer science, and everything. Yeah, it's a sad story how Russian academia used to work at that time. But yeah, I was trying to tackle some things in the space of domain-specific languages. I was interested in generative programming. So I was interested in languages, and I was reading a lot about that. So that's my situation then. And actually, during the year 2010, I was doing an internship with the University of Tartu, where there already were some people who knew something about programming, and it was very interesting to actually hang out with people in your own field. Also, JetBrains in 2010 was not a huge company, but very successful. We had about 300 people, and yeah, and we were not connected, obviously. But I heard about JetBrains. I tried their products, although I was primarily using Eclipse in my programming work. So the company was not huge, but the IDs were very prominent. They were successfully competing with free and very popular Eclipse. They were successfully making money in the space of Visual Studio with C#. And they've just released a couple of specialized IDEs for JavaScript, Python, PHP, and Ruby came a little earlier than that. So this is the context of the company. And at some point, somebody just told me that JetBrains was interested in this language-related project, and why wouldn't I just come by and have a chat? And I was thinking that they were talking about MPS, this project here, which was basically a research project, the idea of one of the founders of JetBrains. It's a pretty interesting thing. They were doing, they made basically an environment for creating domain-specific languages that they looked like text, but they weren't actually textual. The graphical was very interesting, was related to what I was doing. So I was very happy to come by and talk. I'll tell you what happened after I came by, and we talked a little later, but also the context in the world at that time was very relevant. So Java, the programming language and the associated platform, was created at Sun Microsystems in the 90s. And the biggest part of Sun's business was hardware. They were selling servers. So the dot-com crash for the year 2000 was detrimental for Sun because everybody was closing up shop and selling their servers on the just on the market. So they couldn't sell any more servers. And it was like a very sad story of decline of a great company. So in 2009, Sun was acquired by Oracle. And you can imagine, like, this whole turmoil with like business hardships and then acquisition and reorganization. The last meaningful version of Java came out in 2004. And then there were updates, Java 6 and Java 7, but they weren't really significant. Java was falling behind, especially behind C#, and everybody who was doing Java at that time was at least mildly frustrated how backward it was and how unmodern it looked and so on and so forth. So the next meaningful version of Java came in 2014, which was 10 years of a gap, which pissed a lot of people off and also created an opportunity window for us to do something. Yeah, so this is the context. Any questions about the basic historic context here? All right, who remembers the days of Java 5? All right, so you can call me out on something if, yeah, if I don't remember it correctly or I'm trying to mislead you on purpose. So, yeah, as I said, I just came by to talk. While visiting, I was actually interviewing for a position at Google in St. Petersburg. So I was visiting and I dropped by Chet office. And they told me it wasn't about domain-specific languages at all. And it was about a proper programming language. I was like, come on, people. Nobody ever creates a new programming language. All right? Like, this is one thing you shouldn't do. And also, there is Scala. Like, OK, you're not happy with Java. Fine, I'm not either. But there is Scala. Scala's fine. And we had a very interesting conversation because the people I were talking to, they were like, it wasn't something that crossed their mind the day before. They tried Scala, they tried Groovy in production, and they saw the problems. They also tried, well, not just tried, they actually created tooling for both Scala and Groovy and knew the problems there and so on and so forth. So it was a very insightful conversation for me because I was not aware of a lot of things. And the bottom line was that, A, JetBrains was in a kind of a unique position to be able to build new language on the market. Because why you shouldn't create a new language is A, it's a lot of work, and B, nobody cares. But if you're a company with a lot of users who are also developers, they will care. And it did work. So that was one thing. Another thing was that Scala didn't really fit the bill because they tried really hard to make good tooling for Scala. It was like impossible, just because of the complexity of the type system. Also, Scala was heavily reliant on implicits, and the compiler was slow, and they didn't care about compatibility. So people were like, every time a new compiler version came out, you had to recompile everything, and like wait for your favorite libraries to recompile before you can recompile. So it was quite difficult for the Scala community at that time. Yeah, so we had that conversation, and I was like, OK, makes sense. Let's assume we will do the language. Like, what's interesting to you? Like, what kind of conversation do you want? And we started just talking about basically like what we would put in the language. And that was the first day of discussions for Kotlin. Extension functions were on the whiteboard already. And some other features I don't remember, but I remember that the extension functions were there. So this is the context. So basically, we're talking about a very unique situation, a window of opportunity where Java was stagnating for ages, C# was really progressing fast, and everybody was frustrated. Groovy and Scala didn't really fit the bill, and yeah, we need a new language. Any questions about this?
Why the progress of C# is frustrating?
Oh, it's every time you do this, like, what was the boilerplate of the time? I guess every time you do things like, I do not remember good examples, but OK. Well, in any case, C# was adding features that reduced boilerplate, like very consistently, one after the other. And the Java community was super frustrated with boilerplate. Like, Java was well known to be the ceremony language, where you not only have to say like public static void main, which you needed to do in C# as well, but also like you had to produce a lot of boilerplate. And especially like inside an IDE-centric company, people were trying to mitigate that with tools. Like at some point there was this folding capability introduced to the IDE. I think it's standard by now, where like you have a wall of boilerplate, and the IDE will just collapse it all and not show it to you and just say, everything's fine here, just don't look. So this was, I don't think people were trying to like compare and think of C# in the context of their actual project because their projects were tied to the JVM. They couldn't actually adopt C#. But when you see someone else having it so much better, it's very frustrating. More questions? Go ahead.
What was holding Groovy down?
Oh, Groovy. I think there are a few factors there, but the biggest factor was that Groovy was by design a dynamic language. And for a dynamic language, there are essential limitations. It's A, performance, and B, it's toolability, because when you don't have static typing, the tools cannot possibly be smart enough. Yeah, I'll talk a little more about this, but yeah, these are the two like basic foundational problems for Groovy. Also, Groovy was a very interesting effort in terms of like a lot of ideas just piled up without much thought in the beginning. So it's, I don't think it's as much of a mess today as it used to be, but it's, it was visibly difficult for the team to evolve it because of like lack of foresight in the beginning. Okay, so when we set out to work in Kotlin, we thought about requirements, and I don't think we actually wrote them down before we started presenting for the outside, but they were in the air, and like the initial presentations at Kotlin that came in like 2011 or something, they were pretty accurate in terms of what we were thinking about. So here are a few slides from my first presentation. When we presented Kotlin like fairly straightforwardly as a statically typed language for the JVM, for general purpose programming, not for something specific, that we make as JetBrains, so implied good tooling and all that. Also, we were deliberately trying to distance ourselves from Scala, and we're making a point of not making an academic project, a research project, being like super down to earth, and not trying to publish any papers. Also, as motivation, at that time, we just said we wanted Java interoperability, which turned out to be the hardest thing about Kotlin in general. Like, if anybody ever asks you to create a complicated interface with an existing complex system that you do not control, think like not twice, maybe 5 or 7 times before you agree. It is extremely difficult. Yeah, but these are the things we cared about. So interoperability with Java, and we wanted it to work both ways, so that Java can call Kotlin, Kotlin can call Java, and so that it can just drop in a bit of Kotlin into the Java code base, and it just works. We wanted to compile as fast as Java, and I know how much it hurts today. We wanted it to be safer than Java in terms of type safety, more concise, and we were actually, these slides are like extremely diplomatic because like every time you say concise in the Java world of the time, it means like Java sucks so much. But yeah, we were like trying to not bash on Java or Scala too much. Also, we just explicitly wanted it to be safer than Scala, simpler than Scala, of course. And it's, you know, it was a lot of skepticism at the time. So when we first released the initial docs, the compiler wasn't available yet. I released the docs, and there were like, of course, there were enthusiastic people who just believed in JetBrains and would like anything they do. But there was a lot of skepticism, and like, Scala's already there, it's fine. Like, Java will progress fast. And, you know, I couldn't find it today, but there was a tweet that I still remember that said something along the lines of like, there's no point in just making more languages, and ended with, seriously, give up. Yeah, I wish I could find this and just like put it on the wall, because you know, it's a good motivational piece for me. In any case, so these were our requirements, like the way we presented it, and I would summarize it this way. So we were talking about Kotlin as a modern language for industry for years after that. And basically, it was true. This is what we were trying to do. By modern, we meant low ceremony, concise, expressive, something that's, you know, up to the industry standard, or maybe even improving on the industry standard. But also the key thing there was for industry. Because, like Haskell is a great language. I like it very much. But I'm not investing in a team who's trying to build something huge with it, because it's very difficult to scale in terms of people. It's okay to scale in terms of the code base. But people would be expensive, probably. And Scala had the same difficulty. So we wanted to create a language that would make a lot of economical sense for big teams, large code bases, and long projects. So a lot of people working on a huge code base for a long time. And there are some very basic things, like readability comes before conciseness or anything else. Like, you need to make it readable. And the actual reason why we wanted to reduce boilerplate was because boilerplate creates this blind spot when you don't look into it. And if something's changed there, something's not right, you just don't notice. Yeah, it takes hours and hours of debugging. Same thing about safety, type safety, static safety, catches bugs early, and this just saves you effort and ultimately money. But also, on top of that, in an industrial setting, what's expected is good tooling, fast compilation, and these are actual constraints on the language. A lot in the language design depends on these things. Like, to enable tooling, you have to have a type system that makes everything predictable. To make compilation fast, you have to design your module system in a way that will enable actual quick lookups and will not require a lot of lookups where they're not needed. And actually, some languages have a lot of trouble with that, like C and C++, for example, are very slow compilers. Not because the algorithms are bad, just because the way the language works doesn't enable quick lookups. Scala had some other things with implicit search as well. So, and we also emphasized pragmatism, not being academic, and accessibility to all professionals, which is the polite way of saying we're not Haskell or C++ or Scala, where there are style guides that exclude some language features because we can't train our team to use them all. We really wanted Kotlin to be accessible to the entire team everywhere. Also, we understood the problem with, say, Python 2 to 3 transition and the issues with Scala versions. So we wanted to be very serious about backward compatibility. So this is the industrial setting for us. We wanted to distance ourselves from Java as much as we could. And also, it was a very pressing need to distance ourselves from Scala. So, we were kind of, every line here, almost every line says, we're not Scala. It makes sense. Scala exists, but we wanted to do something else because it makes sense. Yeah, and as I mentioned, Java interop. It was a big thing. Any questions about this? Would you like such a language? Okay. So we were obviously not alone. The idea that the language space on the JVM is lacking was very obvious. And other teams started their project. It was so frustrating and nerve-wracking because, it felt like every other week somebody was starting a project. It wasn't like that, actually. It was, they all fit on a slide. But, it's what if they are luckier or do it better or somehow render us obsolete? I was very nervous about that. But turned out, at some point, I was preparing some kind of a talk and needed to just explain the landscape to the audience. And I just sat down and tried to figure out what are the basic requirements, basic ideas behind these languages. And it turned out that everybody was trying to do something different. It wasn't like anybody was doing the same thing as we were. It's just every JVM language was trying to approach it differently. Ceylon was trying to reinvent everything. Their idea was, JDK is bad, let's scrape it, and just create an SDK from scratch. All the classes, everything will be different. The runtime is the same. There is some limited compatibility with stock Java libraries, but we're reinventing everything. And Extend was on the other end of the spectrum, basically. They were trying to say, okay, we don't have a runtime library at all. We generate Java code that compiles against normal libraries with a stock compiler, and so on and so forth. And having done some transpilers in the past, I knew it was like impossible in an industrial setting. I mean, Xtend has its applications, of course, but like imagining a huge code base written in a transpile language is like debugging would be hell and all other things. So it was pretty clear it was a different niche from us. Also, Groovy 2.0, they were trying to like introduce types and be more relevant in larger scale projects. Because also they were keeping the dynamic things around, and all the performance issues would be there, and so on. So it was like everybody was doing it differently, and I was nervous, but it would be actually very interesting to think about the different requirements, analyze them, and see, like, try to predict who will take what kind of part of the market. But it all turned out actually very logically, like some just disappeared and some acquired their niches and stay there. Any questions about these? All right. Okay, so let's talk a little bit about the target audience. So we were, again, trying to do something for the industry at large. And of course, we had our biases. So JetBrains is a specific company and thought, well, it had worked with a lot of users from different companies. But still, like, the internal culture of JetBrains affected our idea of like what a good language is, of course. And JetBrains was this kind of engineering company with like all the power set with engineers. So engineers were making all the decisions, basically. And there was, like, nobody ever left the company because, I don't know, the atmosphere was so comfortable for people who liked to write code. And the average level in the company was very, very much above the industry average. And we, like, it was an arrogant culture in a way, of course, but it was also like based on this idea of like we're making tools that we like to use ourselves because we're engineers and other engineers will also like the tools we make. So the company relied on dogfooding for all the products. Like we were, the basic idea was as a programmer at JetBrains, you take the IDE, you use the IDE, you improve it for yourself and for the users. It was a very horizontal organization with like very little management. Almost everyone wrote code. So there's a story about a guy who, actually, this was the person who introduced me to JetBrains. He, many years before that, started his career as a programmer, but by that time he was a director, like led hundreds of people. And when JetBrains hired him, the founder asked him to write some code for some internal stuff, because everybody writes code here. Even if you're a director, you write code. So that was the culture. And of course, every engineer was very autonomous. There's really little management. People would like have annual meetings, annual one-on-ones with your project lead, and that would be it. Like you have one conversation a year talking about what your priorities are for this year, like what kind of impact you're making in the product, and then you just go and write your code and like have daily stand-ups, and that's it. Yeah, but so the overall idea behind this general approach was that we are making great tools for ourselves, and they become great tools for the industry. And the same applied for Kotlin. So the idea was we are going to improve our productivity at JetBrains. We had huge Java code bases, and therefore we will improve it for everybody else. Does it make sense? Go ahead.
How a company with such a structure, where everyone engineers not fall into a state of a bunch of folks who are writing open source instruments for GitHub, at GitHub, but was able to create products and sell them there?
Well, I think this kind of thing very much depends on two things, like who sets the direction, because there was leadership. Like there were people who created the initial versions of the product, and they were founders and leaders. And also, like, if you think for 2 seconds, you can figure out that GitHub doesn't pay off, and users pay. So yeah, I think the biggest driving force behind people doing useful things was responsibility in front of the users, because part of the culture was also that, like, the issue tracker for JetBrains products was always open to the public, and basically, maybe not the first line of support, but definitely the second line of support was developers. Like, you can get through to the developer responsible for this feature in less than a day. So yeah, it was basically the idea that we're talking to the users, we're helping the users, this is what we do here. Yeah, so I don't think there was, I guess people were doing a lot of let's implement this very complicated and smart algorithm because it's cool. And like, IntelliJ IDEA has a lot of features like that. Like, if you take the time and master the feature, it makes you more productive, but like almost no users do. But also, like, a lot of things were very useful and were based on user feedback and all that. Yeah. More questions? Okay. So in 2010, JetBrains had this huge, long-lived, 10-year-old code base for IntelliJ IDEA. It was millions of lines of code. I don't remember how many, but so it was like a huge project, and it was a desktop application. Today, it's almost the only desktop application written in Java, because basically, in 2010, the age of desktop UI was basically over, and Swing was already like very outdated. And yeah, but there was no other way to make an IDE in Java. So there was basically 2 big desktop applications back in the day: Eclipse and IntelliJ IDEA, and the related IDEs. And we realized that it was not the kind of code everybody was writing, but like not all of it is UI. Most of it, of course, is some business logic, which is similar to whatever everybody else is doing. We also had a successful server-side product, the continuous integration. It's CI, not IC. Continuous integration server TeamCD. So it's a huge server-side Java application. So there we could look at how people do server-side. The whole thing is very engineering-centric, very anti-corporate, you know, all this like no bullshit culture, all of this, and they're good engineers. And the idea was that extrapolating from this, we will get something good for the industry. And the industry, back in the day, was millions of Java developers who are mere mortals, like normal people, smart, wanting to get things done, but it's millions of them. You know, they don't want to master like complicated mathematics or anything like that. Mostly enterprise developers, mostly server-side. There were like little bits of GWT here and there, where you do JavaScript, but in Java. Some Java Mobile Edition, somewhere because Android wasn't big. And yeah, everybody was using Eclipse or IntelliJ, maybe in Spring, so these things didn't change much. This was the context, and yeah, so these were the people we were working for. The idea was we are doing it for like an average Java developer who just hates this boilerplate and wants it to be like more concise, more readable, and more safe at scale. Basically, it was this simple. Questions here? All right. So the timeline, how it all went, we started in 2010. I joined a couple of months after that conversation. We announced in 2011, and a little earlier than that, the name Kotlin was coined because like the initial name for the project was Jet for obvious reasons, but the trademark was taken. And it was a couple of months of pure agony picking a name because, yeah. So names are hard and annoying and unfortunately impactful too. So basically, the requirements for the name were, A, it should be Googleable. B, it shouldn't mean anything very bad in any language. Yeah, and C, it should be recognizable by ear. Like people should be able to guess how you spell it. And we did reasonably well on Googleable. It's impossible to find a name that doesn't mean anything bad in any language. It's like this problem doesn't have a solution. So in German, Kot is dog shit. And also Kotlin sounds like something disgusting in Chinese. I don't remember what it is. Yeah, so, and people do struggle a little bit with catching how do you spell Kotlin by ear, but overall, it wasn't a bad name. And we were like tentatively using it. We first released under the name Project Kotlin, emphasizing that it was a code name, and we'll change it later. But like if you decide to change something later, it never happens. And two things never happened, changing the name and changing the compiler architecture, which was intended as a prototype in the beginning. The idea was we prototype it, we try it on some like more or less toy projects, and then we rewrite the whole compiler because it's obviously this architecture can't be production quality. And yeah, it wasn't production quality, but nobody ever rewrites a prototype. So yeah, lesson learned. Yeah, so the rewrite is being finalized now. It's been 13 years. Yeah, so it was when we announced in 2011, the blog post mentions that the beta was planned for the end of the year. And you all know it didn't happen like that. So yeah, it was a lot of like design and prototyping process, and went much slower than we thought. We open sourced instead of releasing a beta. We open sourced in 2012, and soon after we released first preview build of the compiler, and we went on releasing preview builds of the compiler for 4 more years because I guess the idea there was that we had to get it right because after we release 1.0, we can't change anything because it will be breaking compatibility. And I think this was one of the big mistakes on my part, because what we should have done is release 1.0 somewhere here, like 2013 or something, and just admit that we are gonna break compatibility after 1.0. And this is actually what other people did, like Swift did this a couple of times. They have the advantage of being Swift, but it is a good thing. Like Rust did the same, and they got away with it. So we should have actually have a stable version somewhere here for people to be able to adopt it, and also to focus our efforts, because when you don't have press and deadline, like it's ready when it's ready, you diverge a lot. Like by the time, like here, we already had a JavaScript backend, some other experiments on the side, a lot of things that would have been just cut off if we focused on a tighter deadline. So in any case, this is what happened. And we released in 2016 and spent a year in this kind of like steady growth, which was fine, but we're trying to approach Google this and that way to get like more endorsement on Android, but like nothing worked. And then in 2017, Google approached us and told us that our community really wants this language, so we'd like to announce that the official support at Google I/O this spring, but it's already this spring, and we have like 3 months or something. And we're like, yeah, cool. What are we gonna do? Yeah, so it was a very interesting process of like figuring out. But technically, I mean, we didn't have to prepare much. It was working already. We paid a lot of attention to Kotlin working on Android, but in terms of legal protection for Google, because if you're big enough and everybody wants to sue you, and somebody is already suing you for like $9 billion over Java, you really want to legally protect yourself somehow. And this is how the idea of Kotlin Foundation was created. But we had to flesh it all out in 2 months or something. So yeah, it was quite thrilling. Now I remember we were like, there was the foundation structure in the initial agreement. The foundation was actually incorporated later, but the whole governance structure was already there. And there are like voting rules for the board. And it's a complicated algorithm written in plain legalese. And we were debugging it on a whiteboard with my dev lead for hours, and we were finding bugs and proposing fixes. And like there was this back and forth between us and lawyers, because our fixes maybe made sense on the whiteboard, but then there was like a question of how you put it correctly into legalese English. It was very interesting. I would not like to do it again, though. Yeah, so in this picture, an important a small detail would be that actually Android was not in the picture, like here, for example. When we were announcing Kotlin, we had no idea it should work on Android or anything like that. So basically, the first mention of Android in the issue tracker for Kotlin happened sometime like late 2011. And Android was already a thing, but it wasn't big. And I only a little later, I think somewhere around here, I realized that it was a very good market for Kotlin because of my initial idea was that the general market of mobile apps has a lot of new projects every year. So it's much easier to start a new project in a new language than introduce it to an existing one, even if we enable it very easily. So we were like, okay, let's try to make sure that it works. But at this point, before we realized that, somebody just wrote a question in our forum or something, like, does it work on Android? We're like, I don't know. I heard Android uses Java, that it should work. Do you mind trying? And they tried, and it didn't run. It didn't even properly translate. Like, it failed DEX through a segfault. And we were like, we ended up with this core dump in our issue tracker. And I'm like, okay, great. Like, what kind of C application are we debugging now? Is it like the Android runtime itself, or maybe something else? And it turned out it was DEX. And fortunately, people over in Groovy already got the same issue and have already figured it out and fixed it. So we just looked and did the same. It was something very stupid. Actually, it was an interesting thing, because basically the big difference between Android and the Hotspot JVM is that Hotspot was obviously written before the spec for the Java machine, and Android was written after. So the people who did the Hotspot implementation didn't read the spec, I think. So they are super sloppy about some unimportant things in the spec. Like, for example, by the spec, a class in Java cannot have a flag called ACC static, or there is some very specific semantics around ACC super. Hotspot doesn't care. It will just run. Android does care, and DEX will segfault. And we used to, so basically, after a few bugs like this, we realized that Android was a very good spec checker for us. So we started running Android code verification on every test. Like our test framework, any code you compile in your tests runs through the Android verification. And it was tremendously useful, because these people already read the spec and implemented the checks. It was incredibly useful for us. Yeah, but yeah, we discovered a lot of things about Hotspot and just the Java world in general. Like, we did some of our code did segfault Hotspot, some Hotspot versions, because nobody ever tried to call a method called set on an array before. Because it's obviously not there, and apparently the array class in the JVM doesn't have a virtual method table at all. So if you try to call a method, it's just segfault. All used to segfault. They fixed it, of course. So, you know, there were things like that, but we just discovered by accident. In any case, Android turned out to be a great market for us because Android was even more stuck in the past than the like larger Java community because it was difficult for the virtual machine to adopt new VM level features. Like Java 8 came to Android very, very late. Everybody was, you probably know, everybody was really pissed. And also there was Swift at some point, which also accelerated everything. And you have to do UI, and UI is difficult. And runtime performance and binary size make a lot more difference, and you know, all that. So Android was great for us. Yeah, so this is the context for all our adventures. How am I doing in time? How much longer? Oh, okay. Nice. Okay, any questions about the Android situation and the overall timeline? Go ahead.
Was the creation of Android Studio a way of getting Kotlin in, or was that?
Oh, no, it was the other way around. So basically, I think Android Studio came out in sometime around 13, yeah, something like that. So basically, the Android team was struggling with an Eclipse-based IDE for a long time. It was very difficult. At some point, JetBrains open sourced IntelliJ community, which enabled Google to pick it up and build on top of it. There was a long-standing relationship. I think that happened, I don't remember, sometime around 2012 or 13. So we couldn't predict that when open sourced IntelliJ. But there was already an established relationship between the Android division and JetBrains, which didn't help until the community actually wanted Kotlin. So, you know, it was kind of nice that we had it, but didn't really help directly. More questions?
Going back to the timeline,
Mm-hmm.
you told me about dog-fooding earlier on. Where in that sort of timeline was JetBrains actually dog-fooding?
Oh, that's a good question. So we were obviously dogfooding Kotlin in Kotlin itself from the very early days, but I think, let me remember. So it was definitely very early. So maybe the year 2013, 14, we were already doing some production code somewhere inside JetBrains. So it was definitely 3 years before release. There was definitely a lot of production code in JetBrains already written in Kotlin. There was actually production code written in Kotlin outside of JetBrains before release. Yeah, and I have a lot of respect for the bravery of those people. They are pretty crazy, I think, in a good sense. Yeah, so some of them are actually working in the financial industry, which is double points for courage. Yeah, so our dogfooding started, I think, well, solidly around 2014 or something, but probably formally earlier than that.
Silly question, maybe. Why did Teapot logo? I don't remember that.
Okay, yeah, that's a silly story. So at the time, I don't remember which language in Wikipedia, either English or Russian, stated that the word Kotlin, which is the name of an island in St. Petersburg, Russia, the word Kotlin was supposedly somehow derived from the word kettle in Swedish or something, which is not true. And it was just, you know, we were just bouncing ideas about like what the logo would look like, and we wanted something playful, and we didn't want Google colors there, but nobody thought about that. So yeah, we ended up with this, and it looked nice, and we just kept it for a while. Yeah.
Relates to Java Kotlin?
Kind of, yeah. So the whole thing about T and yeah, so it was probably part of it too, because basically we were desperate about the name, and the logic that followed to Kotlin was we actually took a clue from another competing language. There was a language called Ceylon. And their idea was that Java is the island of coffee and Ceylon is the island of tea. And a colleague of mine, Dmitry Zhamarov, was like, okay, we have an island too. No coffee or tea grows there. Nothing grows there, actually. There's a military base and a huge cathedral. But it's a nice place, and you can see it out of the window. So let's do Kotlin, and the word is like pretty unique. It's easily Googleable, and so on and so forth. Yeah, so T was a part of the chain. But also we quickly, after adopting the name, we realized that there were things named Kotlin in this world other than the island. Like there was a Soviet destroyer ship that was dubbed Kotlin class destroyer by the Americans. And we were like jokingly in my early talks, I would say like Scala is a car, like Renault Scala, and Kotlin is a destroyer, and Haskell is some kind of, I don't remember, some kind of transport ship as well. Yeah, so.
Is there no relation that K comes after J and Kotlin is after Java?
I don't remember if anybody mentioned that. It is a good observation. I'm pretty sure somebody noticed, but nobody really like. Yeah. Yeah, but yeah, good point. More questions.
Are you coffee or tea?
Hmm?
Are you a coffee or a tea man?
Oh yeah, I'm absolutely a tea man. I don't drink coffee at all. Yeah. And that didn't actually, yeah, I don't think it popped up in that conversation. All right. Yeah, go ahead.
Considering that you've been working on the language like for 4 years, or something like that.
In total, so my work was 10 years in total, yeah. First reason was 6 years, yeah, almost. Mhm.
I just was wondering, how do you feel like you were working on a new thing without the promise that it would be financially successful? So do you feel like any pressure?
You know, I was fairly oblivious to the pressure, like to the external pressures. It was, I mentioned this JetBrains culture of like giving a lot of autonomy to engineers. And I think like before maybe 2014 or 15, nobody actually mentioned to me that we were like taking too long. Yeah, so I think I definitely wanted it to be to be more functional and to be able to write real code in it and so on and so forth. But in terms of money, I didn't really think about that because for two reasons. A, there was no agreement between us and the CEO of the company that there will be any like time frame or anything. So it was, an important thing actually to mention. The current CEO of JetBrains was the co-designer of the initial version of Kotlin. And like it was his big passion to create this language. I did like a lot of engineering work, and he contributed a lot himself and was supportive of Kotlin throughout the whole thing. And we had tremendous fun working on the initial design. So I think I was probably also fairly certain that nothing will change in terms of financing the project because he was so much into it. But yeah, so I wasn't really mindful of any of that before maybe, 2016 or something. I didn't really think of like the big scale picture of everything. I had this idea in the beginning that if we reach 100,000 users, I will consider it a success, which did happen, and I'm happy about that. But that was the extent of my, perspective and the success of the project. Go ahead.
How it was when Kotlin compiler did it for the first time? You compiled the code.
Oh, it was like it compiled something fairly early on, so it wasn't a very special moment to me. I guess I don't think there was like one of the big psychological problems for me was that we were like crunching at it for a long time, and I'll mention a little bit of that later, but I was like overworking myself quite a bit. And so I was very caught up in all this. And when we actually released, it wasn't much of a celebration for me. It was just pressure continuing. And then there was this big announcement at Google I/O. And there, like, it was, of course, an event, a celebration. And like people were really happy when they heard the announcement. There was like a lot of applause and all that. But it still like felt like a lot of pressure. And there was one very, somebody did a very nice thing to me. So basically the person behind the whole Kotlin project on the Google side, she was the product director for Android. She arranged meetings, like one-on-one meetings for me with all the key Android engineers at Google, like the day after the conference or something. And they were like mostly director level engineers. And each of them, it was, I don't remember, like 8 meetings or something. And each of them told me how much they liked Kotlin. And like first conversation, I thought they were being polite. But then, you know, when you hear it repeated many times, and like with specific technical arguments why they like it, it actually worked. So when I went to my hotel that evening, it felt like something changed. So, you know, it was not before that. So that was the special moment. But before that, I didn't really pinpoint any specific moment in the history. Yeah, thanks for the question. It was an interesting memory to recall. All right, let's move on. So, yeah, if you think about what it takes to make a language, it is many things, and we had to do all of them. So on the language design side, that's something that's reasonably easy to imagine. It's a lot of details, like from type system to how debuggers work to everything there. But also you need to do all the implementation. It's not only the compiler, it's also like all the libraries, documentation. Takes a lot of time. But also package management is such a pain. Build systems, IDE obviously, debugging, like the implementation of a debugger, especially in a language that inlines anything. And Kotlin inlines a lot. It is a lot of pain. So it's a lot of implementation, of course. But there's also, like for any long project, there's project management. Like we had to figure out which features we work on, which bugs we fix, which bugs we ignore, what's our strategy, like how we sell the new version to the users, like how we process user feedback, how we balance our capacity, our resources with all the needs of all the people out there. It was difficult. And also like the culture at JetBrains was that like one developer, one feature, and you as a developer handle all your users. In the context of Kotlin, it doesn't work like that. Basically, we couldn't apply that very well. Apart from probably some library owners and some IDE features, nothing else works like that because everything is interconnected in the compiler and in the language design. So we had to basically reinvent how we do it, and we changed it a few times, and it was difficult. But also, like, you have to hire the actual team and manage the actual team. And I was not a manager, and I didn't know how to do that. And in 10 years, we were 100 people. And it was an interesting journey. And also, we did partner management. We talked to Google, we talked to Gradle, we talked to other partners working on interesting things or wanting interesting things from us. And also, we managed the community. So it was like a huge project, actually. So I didn't realize I would need to do all that in the beginning. But I ended up the CEO of all this without any like experience relevant to most of it. It was interesting. And when I started, I was 26, and I was overly confident, and I thought I knew everything, and that's a very bad start. And unfortunately, I was like, a lot of skills that were lacking, I could compensate for a while with just running around very fast. Like, I didn't know how to manage people, but I could remember enough things and just context switch fast enough to micromanage 30 engineers that were doing useful work. And so we, I think by 1.0, so by 2016 or something, it was like 30-something people working on Kotlin. And I was basically the only manager. Maybe, no, by that time the IT team was separate and there were 2 managers for that. But like, that was my limit. And we needed more people. And I couldn't scale up to more people. And it was already, like, all my time was already consumed by that. And there was no spare time to figure out how I fix this. Because like my one-on-ones were taking the whole time. And also I was like wearing too many hats. So, you know, fortunately it all worked out, but it was not healthy, and I don't recommend doing that. Yeah, so a few things I would definitely do differently. One thing, I would definitely get a mentor who would care about my growth and not like the project or anything, just about my well-being. And this is what I do now for other tech leads because people need that. And yeah, I'm not sure I would listen from the first try, but I could really benefit from this simple message of like, we believe in you, we think you are good, but you need to learn things. Back in 2010, that would be, yeah, that would have been very useful. But also a few things I didn't get right. We should have grown the team early on, like much more than we did. And since I was teaching a lot, I knew how to work with students, and we were hiring great people from just fresh out of college or from third year in college. And they were like, eventually, they contributed like most of Kotlin. But you know, we heavily lacked on like seasoned experts in the team. And we should have done it differently, which should have hired more experienced people. We should have, oh yeah, we so much should have invested in like growing the prospective managers inside the team, because when you scale up, in an engineering culture, it's very difficult to hire someone from the outside to manage people. Because like, who are you? Do you even write code? Yeah, so we should have invested a lot more into just helping people grow the skills needed to manage. Also, as I mentioned, we should have released earlier. And we ended up, like by 2020, we ran Kotlin. I was not I was formally the project lead, but we actually made all important decisions by consensus of 4 people. So we had this HQ where it was so much easier than just being the boss of everybody. And I should have done it, I don't know, very, very early on. And a lot of the time it felt like, before we had that, it felt like I'm the only person caring about the big picture and like, in many ways, the smartest person in the room. And yeah, if you feel like you're the smartest in the room, you're in the wrong room. And I should have created this room for myself. Any questions about this? All right. So I'm wrapping up, and just an update of like how this all ended for me. So you probably know that Kotlin is used by many, many people, and I'm very happy about that. I departed from Kotlin and JetBrains in late 2019. So it was like the last 2 years of my time there. I was basically preparing my departure, like taking care of all of the management debt that wasn't attended to before, and just to be able to hand it over. A stupidly adventurous thing that I did was co-found a startup while I was the project lead of Kotlin. I don't recommend doing that. It is unhealthy, a lot of fun, and it may kill you. But yeah, so I'm still not operationally involved, but I'm still the co-founder of that. I've been doing well-being help to tech leads, like mentoring and coaching and this kind of thing, because I had some time to reflect on how I handled this very interesting project. Yeah, and I'm looking to make some outsized impact in the future. Probably not as an engineer, because, you know, one thing I learned from doing Kotlin is that even very interesting engineering problems become overly familiar after 10 years. So I'll probably not do much engineering, but I'll be doing something else. So to summarize, my biggest takeaways from this journey of 10 years of Kotlin is, for me, I think it was a big discovery that making a difference is to focus on the things that can only be done if I'm there and not do anything else. It was like this kind of optimization where at the beginning I was doing everything, and then I had to cut everything that anybody else could do and just focus on where I'm actually needed. Also, big achievements don't automatically make you happy. And big effort can automatically make you unhappy. So I have to watch out for that. And yeah, burnout is real. And work-life balance is a misnomer. It's not work-life balance. It's a balance of how you have fun. You can have fun at work, but it will be only one kind of fun. And to be sustainable, you need different kinds of fun in your life. If you can handle 10 jobs, each of which is fun, okay. That's the fun balance. Yeah, so these are my personal takeaways from this story. Here are my contacts, and your questions are welcome. Thank you very much.